Good afternoon, everybody. Welcome to this talk. The second one that I've done today. Was anybody at the first one that I did over at the other place? One or two people. The jokes are the same, the content's a little bit different. Okay. We're going to talk specifically about these two things, actually, AutoAI and Watson OpenScale, which are solving two of the challenges that we face in doing AI. Have we got any data scientists in the audience here? Okay, oh, quite a few. Good. There's still not enough of you, right? There aren't enough data scientists in the world, and that's one of the problems we're looking at. Who saw on the news earlier this week the story about the Apple credit card and how, a few people putting their hands up. So the story was that there was a suggestion that the algorithm that's being used to set credit limits for the Apple credit card, it's being issued by a bank in the US, is biased, and it's biased in favor of men. And that's another one of the things that we're going to be talking about, the whole issue of bias in AI and the solutions that we have for that. So let's get into it. I'll just introduce myself a little bit first. So I'm Chris Williams. I'm from IBM. And I work in the part of IBM called Watson, which is where we do all the cool things with AI. It's the most interesting part of IBM to work. And I've been doing that since we launched Watson here in Europe 6 years ago. And before that, I was a big data person, right? I had big data in my job title. So this is a bit like coming home, coming to a big data conference. And everything's kind of come back together full circle. I was saying actually at the beginning of my previous talk that when we used to do big data back in the day when before I was doing Watson, I always felt like we were working really hard to bring lots of different types of data together, but we didn't really know why. We didn't know what we were going to do with it. And then I guess over the last few years, the answer has become clear. What we're going to do with it is AI and machine learning. And we're going to do that in ways that we've not done before. So that's really what we're going to talk about. So, as it says there, the world's changed, right? A lot of things have changed. I sometimes do a whole talk about the history of AI and how we've got to where we are. And I go right back to ancient Greek mythology and I work forwards, right, to where we are today. And we're at a really interesting point in the history of AI. For a number of reasons. Sometimes I call it the perfect storm. But one of the reasons why is because the world is ready for it. Right? Business needs it. We've run out of other ways of optimizing. We need AI to become mainstream. We need AI to be part of everything that we do. People's expectations, consumers' expectations, employees' expectations are much, much higher. They expect organizations to be able to deliver really engaging, personalized experiences, and they expect them to make decisions that are transparent and fair and very tailored to the individual. And the only way we're going to do that is with AI. So this is the kind of things that we do in IBM. So for sure, we do a lot of research, probably as much research, if not more, than anybody else in the world of AI. If you went into IBM research, you'd find that a significant number of the people who are working there are working on things to do with AI. And this is the key thing. Okay? We're trying to take AI out of the world of experimentation, out of the world of the lab, and make it part of the way that business runs every day. Move it into production, as it says there. And also, thinking about the bigger picture, right? What does the world of work look like, right? When we're all doing AI, okay? The world of work is going to change. It is already changing. What does that mean? Okay, we're not going to go much into that today, but it's the sort of thing that we think about all the time in IBM. And if you want to talk more about that, you can come to our stand, which is over in the other hall, and I'm sure we can talk about that. So what do we need to do to bring together machines and humans in a better way? Right? If the machines are going to be more intelligent, what happens when we bring them together? How can we prepare for that world? So here's a bold prediction. Okay. Says that by 2025, half of what data scientists are doing will be automated, okay? And that will address this talent shortage, right? because there aren't enough data scientists in the audience, right? Okay. So what does that really mean? Right? It means we're going to be using AI to generate the AI. What does that look like in reality? And there's another challenge here, which is that when we go and talk to our clients about AI, they have some uncertainty. They're not sure about what it really means. Can they trust it? Are they going to get the outcomes that they need for their business? All right. Okay, so let's look at some of these. Is the AI model doing what we expect it to do? Is it going to work in the way that I want it to? And how do I measure that? Right? How do I measure whether my AI model is working, whether it's adding value, and whether it's doing what I expect it to do? Okay? How do I monitor it? And who knows how a business works best? The answer is the people who work in that business, the people who have that knowledge, that expertise in their heads. How can they feed that in if they're not data scientists? How can we make it so that the people with the domain expertise, the people who really understand what the data is telling us, are able to work collaboratively, that's a hard word to say, isn't it? Collaboratively alongside the data scientists. How can we get those two people who, in a sense, speak a different language, working together more effectively? So that's the kind of challenge that we're thinking about all the time in order to tackle some of this. And these come out of something called an IBM Institute for Business Values study, which you can find online if you're interested in more of that. So what do we do about this stuff? So as you would expect, we're IBM, we have technology to help to address this. And I talked in my previous talk, for those of you who were there, about this thing called the AI ladder. Okay? The foundation on which you build AI, the steps you have to take to get from data, which is the fuel for AI, to insight that you can, as it says there, and it's a really, really good word, infuse into your business. What does that mean? And the answer is that you need to have tools and techniques and ways of working that support every stage of that ladder. And it needs to be done in a way which is collaborative and which has governance around it. And that governance needs to be controlled quite carefully, because on the one hand, we want to make sure that people can only work with the data that they're allowed to see and that they're constrained in some ways, but we don't want to stifle their creativity. One of the things that's changed, one of the things that is part of this perfect storm that I talk about, is that AI is no longer just about playing with the numbers. AI is about creativity, it's about telling the story. It's about bringing it to life, and it's about working out what does this mean for my business so that I can infuse that into part of the everyday life. Okay? So I don't want to stifle that creativity. And we start to look at things like this, and the last session I did was all about this, but we have this platform called the Cloud Pack for Data, which you can run on our cloud or on other clouds or even on-premise and in other places. We have a foundation of database and data integration and governance tools that sit here. And then we have these family of AI capabilities and tools that are all about what happens as you move from analyze into infuse. Right? As you start to think about what does this really mean to make this part of business as usual. And that's what we're going to talk about today. So knowledge catalog, as the name implies, is a kind of a shop window for all the data and AI assets that exist within your organization. So think about the way that things work today. Do you have, or can you be sure that you don't have, two people effectively spending a lot of time building what is essentially the same data set? Two people effectively building a very similar machine learning model to solve a problem. If those two people were able to share those assets more readily in a really simple way and search for them, maybe we could make everything more efficient, start to address that skill shortage that we talked about before. And then, where are all these different stakeholders going to work? So we're talking about data scientists for sure, but we're also, as I said before, talking about business people. Business people are going to get involved in this process. If we're going to infuse this into applications, we need developers to be part of this. We need data engineers. Anyone in here consider themselves to be a data engineer rather than a data scientist? Yeah, a few people, right? That term didn't really exist a few years ago, and it's a really important distinction, okay? Because we can separate some of what goes on in this organized layer and some of the early parts of the analyze layer from some of the stuff that goes on higher up. But how do we get those people, those roles, to collaborate together and share? They do it through this tool called Watson Studio. And Watson Studio, its main premise is to bring people together but allow them to carry on using the tools and the languages that they love. So things like Jupyter notebooks, writing things in Python, writing things in R, the things that they're used to and the things that they want to use, but in a slightly more controlled, more collaborative environment. That's what Watson Studio is all about. And then this, our runtime environment, being able to deploy those models and run them and build them actually in an environment, maybe on the cloud, where we can flex the amount of resources that we need to give to them. And finally, OpenScale. I'm going to talk a lot more about this in a minute, which is where we look for bias and for what we call trust and transparency. There's a bit more detail here. I've said most of this already, but there's something important going on down here, which is this thing called AutoAI, and we're going to talk about that in a bit more detail in a minute. Because remember, we said that part of our goal is to automate as much of this process as possible, to use AI to build the AI, to take out some of the more tedious parts of this and get people involved in building models who maybe don't have as much deep data science expertise, so that we can make ourselves more able to do more with AI. So these are some of the things that we're able to do. Okay. So this is just building on what we've said already. Okay. So the idea of running on multiple clouds, it's built on top of Red Hat OpenShift. We can do all the stages of the ladder in one environment, and we can deploy it wherever we like. Okay. So this is starting to sound like we've taken data science out of a kind of a small experimentation corner of the business, and we're putting it into the mainstream. We're building processes around this that are repeatable, that we can deploy in multiple ways, and we can make use of all the software that's in there. Okay. This is Watson Studio Premium, which is the top tier of all this. So being able to automate, we'll talk more about that in a minute. Get everybody working together, as it says. Future-proofing, so it's using new things like AutoAI, it's using other things that you might recognize from us like SPSS. Okay, if people are using SPSS, they can carry on using that within this new environment. Yeah, we do a lot around optimization, which I'll talk about in a minute. Okay, so why would you want to do this in the first place? Okay, well, we've talked already about the kind of skills shortage, but also we want to get to answers more quickly. You want to be able to build models more quickly. And then this idea of the citizen data scientist. Anyone here consider themselves to be a citizen data scientist? Yeah, there's a lady down here and one or two other people. Okay. So this is the idea that maybe in the future we're all going to be doing a bit of data science. Data science isn't going to be something quite so mysterious. Okay. And then we have to be able to govern and monitor AI. Okay. What we can't do is deploy a model that needs constant kind of feeding and watering and needs the data scientists to be looking at it all the time and tweaking it. We want to be able to look at it and understand from a business perspective, what's this model doing? How's it performing? Is it doing what we expect it to do? Can I explain what it's doing? Okay, there's a great little article here from Forbes you can read about why machine learning models crash and burn in production. Okay, you take them out of the lab, you put them into the real world, and they don't work. Okay, so how do we prevent that? How do we mitigate against that? Okay, so AutoAI. AutoAI won this award at the AI Conics in San Francisco earlier this year. Okay, and the reason why is because it's one of the most matured examples that there is of this idea of intelligently automating the model building process, the AI process. So let's talk a little bit more about what that means. So first of all, let's see what our clients are able to say about it. So a healthcare insurer, okay? The first thing they do, they're saying, the first thing we do, when we've got a data set, the first thing we do is we put it through AutoAI. They test it out. They're looking for signals. They're looking to see whether this is a data set that's even worth working with. Okay? And they can do that really, really quickly. Okay? And there's another interesting thing. Okay? Data scientists taking automatically generated AI, comparing it with their own models, and finding that in some cases, an auto-generated AI model outperforms what they're able to build for themselves. Does that mean they're out of a job? Of course it doesn't, right? What it means is that they can take and learn from what's been generated and feed that into further development of the model. Okay? And being able to get into things like feature engineering, which we'll talk about in a minute. So what we're finding is that when we give this tool to people, they love it. Okay? So how does it work? So at a really simple level, how it works is you start over here with a data set, you give it an outcome that you want to try and predict or classify, and stuff happens, and out the other end comes a model that you can use, right? Okay? And that process is provided that you've given it the data, and you've given it some kind of goal that you're trying to reach. The rest just happens, okay? What does it look like? Well, it looks like a bit like this, okay? So at all stages, you're being given visualizations. This is all happening in Watson Studio. If you want to see this stuff in action, come over to the stand. There's a smart chap there called Dusan who'll be able to take you right the way through this and show you how it all works. Okay? So why would we do this? Why would you want to do this as a user? So get to your models faster. Skills gap we've talked about. Discovering more about what you can do with the data sets that you've got. Okay? Finding those signals in the noise. Okay? What are the features that I should be using in my models? Which ones are going to give me the best results? Okay? This is the sort of stuff that data engineers and data scientists work together on, and they spend a lot of time just fiddling about with the data before you get to the point where actually really building the models. Just automating that part of it is really useful. Comparing different approaches, comparing different pipelines, seeing what works. Okay? And then, once you've built these things, deploy them, get them out there. Okay? Deploy them into our machine learning environment or into other runtime environments. This is a nice picture which just kind of shows us all of the things that we're doing. So there's been some various aspects of auto machine learning, auto AI type techniques around for a while. Okay? They tend to focus on one or two areas. So data preparation, there's some things that kind of help to just assess quality and get some of the data prepared. Feature engineering is something that's been around for a while. And then some hyperparameter optimization, so playing around with the knobs and dials on the models themselves. But what we're doing is we're automating the whole life cycle. So you're starting with your data set and your goal, and everything that you need to do to get through to a model is there and ready to go. So that's AutoAI. As I say, if you want to know more about AutoAI and how it works and see it in practice, come over to our stand and we'll take you through that. Okay. So let's shift gears. Let's talk about OpenScale. OpenScale was on the right-hand side of our original diagram of all these stages. OpenScale is where we monitor models that are in production. So you've got a model deployed, and you want to know how it's performing. And you want to look at that actually through a number of different lenses. So we've talked already at the beginning about this idea of looking for bias. Can I detect any bias that's inadvertently crept into my model? Can the tool recommend to me steps that I can take to mitigate the bias? Secondly, how can I explain what this model is doing? If this model is making a decision, maybe it's a credit decision, maybe it's making a recommendation to a customer, How can I explain why it's done that? Why might I need to explain it? Well, somebody might ask me, right? A regulator might ask me. An auditor might ask me. The customer themselves might ask me. Okay? They might say, why did you make this decision? What were the inputs that led you to make that decision? So that's what we do. Now, the other thing is, I build my model today. Next week, is it still doing what I expected it to do? Or have changes in the external environment, in the data, mean that that model is no longer performing as well as it used to? How can I detect that? Something that we call drift. And ultimately, how can I measure the model? How can I make sure it's doing what I need it to do? So, here's some of the latest things that we put into OpenScale. OpenScale's been around for about a year now. Okay, people are really starting to use it and benefit from it. We've done a lot of work to really give you metrics that explain exactly what's going on in your models as they run in production. Okay. Model resilience. This is a massive area of focus for us. So this idea of monitoring rather the drift in a model. Okay. Looking to see what are the features that are causing drift. What are the external factors? What's changed in the data? Which features should I look at in order to understand why this model is no longer appropriate? And then being able to support multiple runtimes. So we recognize that our clients deploy these models into lots of different environments, so gradually we're adding more and more support for different model runtime environments, so that so you can use OpenScale even if you're not using a full IBM stack to do your building and your deployment. So yeah, so let's talk a bit about this. So Fairness 360 is something which is open source. So you can go and get Fairness 360. It's something that IBM built and donated to the open source community. It's code that you can embed into your own processes. Okay, so you can take that and you can use it. It's a toolkit. Okay. However, if you want to take that to the next level and have this monitoring that sits over the top of that, then you need OpenScale. OpenScale is the tool that makes that happen, okay, in a runtime environment. So I guess if you were really smart, you could take Fairness 360 and build your own tool, but why would you do that, right? We've built one for you. Now, usually at this point, if we're in a smaller forum, someone by now will have said to me, "Sounds interesting, Chris, but how does it work?" Right? If I've got a model that's very opaque, something like a neural network, maybe even, how on earth can I explain what that's doing? Right? How is that possible? And the short answer, and if you want a longer answer, come to the stand and we'll go through it in more detail. But the short answer is that thing up there that begins with P. It's a really hard word to say. Perturbation analysis. What we do is we perturb the inputs to the model. We make small adjustments to them, tiny variations, and we look at what effect does that have on the output. And we do that at scale. What it allows us to do is to create these things called risk models and explanation models. Okay? And actually the explanation models, as you can see there, fall into two categories. So there's the what did this thing do? So playing back, what are the reasons why the algorithm has made a particular decision, but also this contrastive thing, which is how we do the drift modeling, right? So looking at how it's performing compared to how it would have performed with data from previously. Okay, so a little look at drift in a bit more detail. So the whole idea here is to create a metric which allows you to very quickly see how close is the model's behavior in the current world to how it was when I deployed it, or how was it last week, or how was it last month. Okay. It also tries to predict, based on the trend, how it's degrading over time. So at what point will it have degraded enough that I might need to deploy a new model? Okay, and you can see here that it's those evaluations happen on a cycle. Okay, so we do an evaluation on a cycle, and we provide these all through the OpenScale dashboard. Okay. This is something that's interesting from a regulatory perspective. Okay, so we're starting to tie OpenScale and its general purpose ability to explain and govern AI models with some of the other stuff that we do in a regulatory framework. So particularly in financial services, where it's very, very important that you can not only detect and measure in isolation what the AI model is doing, but you also need to be able to plug that in to your broader risk profile. So model performance potentially has an impact upon your overall risk exposure. So being able to tie those two things together. So that's OpenScale. So we've talked about AutoAI as a way of automating the AI process, and we've talked about OpenScale as a way of monitoring models, looking for bias, introducing trust and transparency, explainability, looking for things like drift, and just overall being able to monitor the performance of our models. If you want to know more about this, as I've said before, come over to our stand, which is over in the other hall. You can get started now because this stuff is on the IBM cloud. Go there. Both the AutoAI, which is part of Watson Studio, Watson OpenScale are there. There are free versions you can try out for yourselves, experiment with your own models and see what works. Okay, so I've probably got about 2 or 3 minutes for questions if anybody wants to ask me a question.